Alwin Kumar, method to reproduce physical and virtual biomodel of a sphenoid sinus and nasal passage structures.
Okay, good afternoon, ladies and gentlemen. So my name is Alwin Kumar. So I'd like to present you with a particular paper. Okay. So just to give an overview. Okay. So we are doing biomodels. So biomodels are actually a replica of the human anatomy. So these are actually replica of the actual human anatomy, and I'll tell you all the details of that. So how do we do it? So it's quite very simple. What we do is we take CT scans and MRI scans. Okay, so these are actual like X-rays. You take multiple slices of your head or anatomy of the body parts, and then what we do is we process it. That's how the X-ray looks like, the CT scan, MRI scan. Then we do image processing. So this is the complex part of the thing. Okay, so what we do is we do outlining first, and then the data in the CT scan, it can't be used directly to generate the biomodels. So we have to do some post-processing. That's point clouds. Okay, that's the original data that comes out. Then we have to join all the lines in the point clouds together, and then we create a surface, and then we get something like that. Okay, so the 3D data. So this data is, we call it the virtual biomodel because it can be seen in your computer, but for us, maybe computer scientists and all of us, we can appreciate, okay, virtual model, we can appreciate using it on a computer. But medical surgeons, they still prefer to use it hands-on approach, okay, because they've been trained to use hands-on. So the next stage is a rapid prototyping machine. So we actually feed that data that we had earlier into this machine. So in my place, we've got two types of machine. One is a powder-based machine. It's actually like your normal laser printer, but actually it prints in 3D layers. Okay, and we create this physical biomodel. Okay, so why do we have to use biomodels? So we came up on this topic because you see, for example, the first picture there. Okay, this one. This is how surgeons are trained all over the world. Because we've had experience, we've invited surgeons from all the world and we've had discussions with everyone. This is how they are trained. You know how it's quite scary also. Okay, in university, because we've got two hospitals in our own university. It's quite scary where the junior surgeons, they actually train on live patients. So you have to be very careful that you're not the one that surgeons are training on. So the other option that they have is to actually use real skulls like this. But then what are you going to learn? You can't actually learn nothing much from there because you can learn the anatomy, but you can't get any soft tissue structures and all that. Okay, and so what we have come up with is this thing biomodel. So we've actually used this in training surgeons, and we've actually shipped it out to all over the world. And currently now surgeons are starting to use models like this to train themselves and all their junior surgeons. Okay, so these are not for medical students, it's for more surgeons who want to train on specialized procedures and all that. Okay, so the next reason why you want to use this is the actual case in my hospital. Okay, so why you want to use it? You want to have pre-operative planning. That is a kind of, because now for example you have all the CT scans and all that, you can't actually visualize what you're going to operate and how you're going to operate. So when we printed out these models for them, they really appreciated it. So they can actually plan, okay? There's a group of surgeons, they're planning on how to operate on a small kit, okay? So they can plan which direction they want to go in and what are the cuts they want to do by these biomodels, okay? So for this particular conference paper, I'm working on this kind of project. This project is actually I'm going to focus on sphenoid sinus. This is actually a region behind your nose, okay? It looks like a cup region where the tumor commonly occurs there. It's a kind of a common area for tumor growth inside your head. Okay, so we've all heard about sinuses. So sinuses actually holes inside your skull. Okay, so this is also quite important because this is how the surgeons, they will go in to get to the tumor. Okay, so we have to reproduce this also. So you must be quite accurate in the reproduction of this. Okay, so this is the current paper I'm presenting here. So we actually created a biomodel of the sphenoid sinus of this particular region. So my group, we have created a lot of types of biomodels, and this is the one I'm going to show you now. Okay, so the method was the same method. We got the CT scan, we got the MRI scan, we did a region of interest, image processing, and 3D model segment. So we managed to create, we have to create the tumor, the sinuses, the bone, and the skin. So using various different kinds of algorithms, we created, this is actually a picture of the sinuses. Okay, it's more details available on the paper. And then this is, after that I printed out the whole thing, and this is how it looks like. And our printer, one of our printer is a multi-color printer. So we can actually generate different colors for different portions. And you can see the red part there, that is actually the tumor. And then we actually tested it real life. Okay, you can check out on my website. So we've actually tested using real equipment. So compared to other kinds of simulation training, they actually use kind of fake equipment or use the haptic sensors. So here we've actually tested it on real equipment, and the surgeons really loved it because they said we can actually train the junior surgeons on how it will look like in real life also. Okay, and medical equipment and medical instruments also. And this is a picture we have taken of inside the nasal region, inside the nose. Okay, it looks real. The surgeons, the feedback we've got is the surgeons say that it really looks like the real patient, the one they've done that. And we've actually published that feedback in another paper. Okay, and this is a picture of the tumor, and this is actually like the equipment they used to try to take it out, and they were like quite happy with the results they obtained. Okay, so thank you very much. And do you have any questions? So I'm actually holding another fake skull. There are some real skulls, but this one is a fake skull.
So is there any question? Okay, I have a question for you.
Yes, there is one.
Okay.
Well, you can also ask you.
Okay, you first.
Okay. I'm not that familiar with 3D printers, but how can you manage that different, let's say, materials inside or have different density and all?
Yeah. So that is the latest technology, because we just bought another printer that just came out last year.
Okay.
So this printer can actually print in multiple materials.
Okay.
So now we're trying to print out, because just now earlier you saw that thing was, this one is all in the same material but different colors. And now we're trying with this new printer where you can print in multiple textures and like rubber and plastic. You can actually combine both. And the surgeons are very happy because they're saying that it really gives them like a feeling of cutting through skin and brain and hitting on the tumor, which is a bit harder.